So this is question number 41 from IIT JAM 2022 paper. So we have to find the value of the limit. So it is rounded off to 2 decimal places. Okay. So the value of the limit we have to find. So here you can see that there are two parts of this limit. So we will divide this into two things. So first one is this series and we will solve this and this separately. Okay. So let's take. So we have limit n tends to infinity. So if we solve for this part, so if we take a common of 1 by n, so it will look like this 1 by n. So out of n to the power 5 is there, so n to the power 4 will be there. So 1 by n to the power 4 plus 2 by n to the power 4 up to n by n to the power 4. And if we take this limit, so n tends to infinity, 1 by n, you can write it as summation r equal to 0 to n r by n to the power 4. Okay, so you can also put over here as r equal to 1. Okay, so you can also put as r equal to 1 in this one. So we can make it in an integral form. So it is if we consider that x is equal to r by n, so dx is equal to 1 by n. So for r equal to 0, x tends to 0, and r is equal to 1, x tends to n. Sorry, r tends to n. So r tends to r equal to n, x tends to 1. So we can write the integral in this manner. Integral of 0 to 1 x to the power 4 dx. So it is nothing but x to the power 5 by 5, 0 and 1. So you can write the value of the integral as 1.5 or 0.2. Now going to the second part of the sum, this solving the square root. So if we similarly take 1 by root n as a common from the second expression, so we can write that limit n tends to infinity. So if we take 1 by root n common, so it will be 1 by root n square. One by root n square. So here it will be, so we have 1 by root over 1 by n plus 1 by root over 2 by n up to, so it is 1 by 4 is there, so it will be root over 1 by root over 4. So we can write this root over 4 as, so we can rewrite this equation limit n tends to infinity, so it is 1 by n, and we can write it as 1 by root over 1 by n plus 1 by root over 2 by n. After that it will go like this. So we can write 4 as 1 plus 3n by n. Okay. Now if we put this r equal to 3n, okay, so we can write it this equation as limit limit as n tends to infinity, okay, 1 by n integral of r equal to 1 to 3n one by root over 1 plus r by n. So we have taken the same thing actually. We will do the x of this r by n. So dx will be 1 by n. Okay. So that is the thing. Now r equal to 1 to 3n. So r equal to 1 will be this root over 1 by root over 1 plus 1 by n, and r over this 1 by root this 3n by n. So when r equal to 3n, so it will be 1 by n. So this range is from r equal to 1 to r equal to 3. Okay. So this is the value. That's 3 is the value. So now find the integral from here. So to convert into integral, we have to write this from 0 to 3. So x equal to rn. So rn r is equal to 0. When r is equal to this tends to 0, r equal to 0. So x is 1 by n. Since n tends to infinity, so x will be 0. And similarly, when r equal to 3n, so x equal to be 3. So here the upper limit will be 3. So now we have the dx 1 plus x root over 1 plus x. So we can also simplify it as 0 to 3, 1 plus x to the power minus half dx, right? So if we simplify this, what will after derivative we will get 2 into 1 plus x to the power half 0 to 0 to 3. Okay. So from there we can see that it will be, the value will be 2. So from here you can see that this is, we have the 0.2 over here, and from the first expression, and from the second expression we have 2. So the summation is 2.2. okay. So it is equal to, rounded up to 2 decimal places. So the value of the limit is, we can write this. So it is coming as 2.2. So we can write it as 2.19 to 2.21. So question number 42 says that consider the function u. R3 belongs to R. So you have these 3 points, x1, x2, x3. So it is given in this by this expression, and say let C belongs to this R and K belongs to the set of natural numbers, such that x1 del u del x2 plus 2x2 del u del x2 evaluated at this point t2 t square t cube equals this ct to the power k. So this differential equation, partial differential, which is the value c to the power k at this particular point, t square and tq. So we have to find the value of k from here. Okay. So now let us find first of all from the expression what is del u del x2. So if we do the differentiation, so what we will get, 4 of x1 x2 cube x3 square minus 52 x1 square x2 x3 cube. Okay. So we have x1 multiplied by both sides. So if you multiply x1 del u del x2, what it will look like? So 4 of x1 square minus x2 cube minus x3 square minus 52 x1 cube x2 x3 cube. Similarly, if we do the del u del x3, so what we will get? So in this we will get del u del x2 4 x1 square x2 cube x3 square. So that is for the first one. So if we do with respect to x3, okay, so it will be 2 x1 x to the power 4 x3 minus 4 x1 cube x3 cube minus it will be 78 x1 square x2 square x3 square. Right. Now if we do this 2 of x2 del u del x3, so in that what will be the result? So 4 of x1 x2 to the power 5 x3 minus 8 x1 cube x2 x3 cube, right, and minus it will be minus 156. Okay, minus 156 x1 square x2 it will be cube and x3 square. So now we have to find the value, this value at the point t square and t cube. So if we find the value of this x1 del u del x2 at the point t square t cube, then we will see that here it will be, if you simplify all of these things, so it will be 4 to the power 14. So put this value of x as equal to t, x2 is t square, x3 is t cube. Okay, so this is the x1 x2 x3. Okay, so on the right hand side it will be 4 t to the power 4 minus 52 of t to the power 4, so it will be minus 48 t to the power 14. Okay, this to the power 14. Now if we do the same thing over here, that 2 of x2 del u del x3 at t square t cube, so we will have this 4 t to the power 14, okay, minus 8 t to the power 14 minus 156 t to the power 4. So it is coming around minus 160 t to the power 14. So we have been given that if we write this as x1 del u del x2, right? So let us check with the expression once. Yes. x1 del 2 del u del x2 plus 2x2 plus 2x2 del u del x3. So it is given as so this value at t square t cube is given as c t to the power k. So we already have, for the first one is minus 48 t to the power 14 minus 160 t to the power 14. So it is coming as minus 208 t to the power 14. So we have to find the value of k. K is equal to 14. Okay, so this is our result. So yes, then the value of k will be